So, now let us go to second problem or second example. Here we have the numerator as x minus sin x and denominator is x cubed. When x is near 0, x minus sin x is 0 and x cubed also 0. So, we try to apply L'Hopital's rule. So, if this limit exists, that will be equal to limit x goes to 0, 1 minus cosine x by 3 x square. It is the other way around. If the right limit exists, then the left also will exist. Now, right one, if you take x goes to 0, again 1 minus cosine x becomes 0, 3 x square also becomes 0. So, you can apply L'Hopital's rule once more. So, that gives minus cosine x, derivative is sin x, 3 x square gives 6 x. So, you get sin x by 6 x. So, now what do we do? You may think of applying L'Hopital again. So, that gives cosine x on the top, down 6, that is 1 by 6. However, it is correct, there is nothing wrong, but there is a comment. See, when evaluating sin x by x, what we have done? We differentiate on the numerator, that gives cosine x, denominator gives 1, fine. But there we are really committing some circularity, right, because how do you evaluate derivative of sin x? So, derivative of sin x will be sin of x plus h minus sin of x divided by h, limit h goes to 0. Then you apply, you use your sin a plus b formula or even the half angle formulas. So, that will give you 2 cosine x plus h by 2 into sin of h by 2 divided by h. So, these 2 we can bring here as h by 2. This is same thing as limit h by 2 goes to 0. Okay. Now, you see cosine of x plus h by 2 as h goes to 0 gives you cosine x. And what about sin h by 2 by h by 2? It is sin theta by theta form, right. That we had proved independently that it is equal to 1. Therefore, this will give us cos x. So, that means in evaluating the derivative of sin x, we are using the limit sin x by x as x goes to 0. Therefore, it is really a bit circular to use like this. Okay. So, you would better say this is equal to 1 by 6 directly, because we know limit sin x by x as x goes to 0 equal to 1. But this is not wrong, it will give the same answer anyway. So, this is equal to 1 by x, 1 by 6. Okay. Let us go to third problem. It says to evaluate sin x by x square as x goes to 0 plus. We are interested in one sided limit only. So, again it is in 0 by 0 form. So, you differentiate the denominator, differentiate the numerator, that gives numerator gives cosine x, denominator gives 2x. Now, this is again in 0 by 0 form, right, cosine x by x. You can use L'Hopital's rule again here. So, that would give limit x goes to 0 plus minus sin x by 2. Okay. Is that right? And that would give 0. So, what is wrong? Why does it give 0 and why does it give infinity? There is a simple reason. Reason is when you apply L'Hopital's rule, you must see that it is in 0 by 0 form. Now, when you use cosine x as x goes to 0 plus, cosine x really goes to 1. So, it is not in 0 by 0 form, fine, and that is exactly the reason it is in 1 by 0 form, x goes to 0 plus, that gives the answer as infinity, not this one. This will be wrong. So, you have to be really observant, not go on applying mechanically. We have to see whether it is satisfying all the conditions in L'Hopital's rule or not. So, you would say limit x goes to 0 plus is infinity of sin x by x square. Now, let us see the fourth one. Fourth one is similar to that. We have sin x by x square, that is in 0 by 0 form, that gives cosine x by 2x, x goes to 0 minus. So, when x is negative, cosine x of course is 1, this gives negative. So, it becomes minus infinity. right. So, limit x goes to 0 of sin x by x square does not exist, neither even infinity nor even minus infinity. Okay. So, let us see the fifth one. Here we have the numerator 1 minus cos x, denominator is x plus x square as x goes to 0. So, as x goes to 0, numerator is 1 minus 1, that is 0, and denominator is 0. So, we can apply L'Hopital's rule. So, that gives 1 is 0 minus cosine x gives sin x, differentiation. Then x plus x square gives 1 plus 2x. Here sin x of course gives 0, but denominator does not give 0. So, we cannot apply L'Hopital's rule, but we do not need, right. If x goes to 0, top one goes to 0, down becomes 1. So, it should be 0, but if you go in a wrong way, that would give cosine x by 2, sin x gives cosine x, and this it will be half, which will be wrong, right. So, the reason is this is not in the indeterminate form 0 by 0, its limit should be equal to 0 really, right, as you see. Okay. Now, let us go to sixth one. So, here we try to find limit x goes to pi by 2 of secant x by 1 plus tan x, but pi by 2. So, tan x has problem, tan x blows up to infinity, secant x also goes to infinity. Okay. So, it is in infinity by infinity form, not 0 by 0 form. There of course, we can use L'Hopital's rule that we have commented earlier, but there is another problem that at x by 2, x equal to pi by 2, they are not continuous functions. Okay. So, we cannot say x goes to pi by 2 plus here, okay. Pi by 2 minus is easy to see, but we have to see also pi by 2 plus from the other interval, that is from pi by 2 to pi by 2 plus delta, and on the left side we have pi by 2 minus delta to pi by 2. So, both the things we have to consider separately, we cannot consider at a time because it is not continuous there. Okay. So, let us take the one sided limits. Now, when x is smaller than 5 by 2, but it is near 5 by 2, we have secant x by 1 plus tan x, which is in infinity by infinity form. We apply L'Hopital's rule. So, derivative of secant x gives sec x plus into tan x, and derivative of 1 plus tan x gives 1 0, and tan x gives secant square x. So, it is this limit. Now, what happens? Again when it goes to pi by 2, it is in infinity by infinity form, but at least one sec x we can cancel here, right. So, one secant x is cancelled. We have now sin x by secant x, that is tan x by secant x, which is sin x by cos x into sec x, cos x and sec x becomes 1. So, this is really this whole thing is equal to sin x, right. So, you do not have to apply L'Hopital's rule blindly again because it simplifies. So, it simplifies to sin x. Therefore, when x goes to pi by 2 minus, it will be sin x, x goes to pi by 2 minus, which is 1, all right. So, let us take the right side limit. So, when you take the right side limit, x goes to pi by 2 plus. So, again here on the top one it becomes only plus, the same thing it becomes again plus, it is sin x, that is also 1. Therefore, we say limit of that function given is equal to 1. Okay. Sometimes we have to take one sided limits this way. Let us go to next problem. Here we want to find the limit as x goes to infinity. It is not one point like pi by 2, it goes to infinity. So, naturally it will be one sided limit, from the left side we are approaching, making x larger and larger, of x minus 2x square divided by 3x square plus 5x, which when x goes to infinity, it is in infinity by infinity form. So, applying L'Hopital's rule, we have x gives 1, minus 2x square gives minus 4x, and then denominator we have 3x square gives 6x, 5x gives 5. So, it is okay. Now, here when x goes to infinity, numerator goes to minus infinity, denominator goes to infinity. So, again it is in the form minus infinity by infinity, which is also indeterminate form. But we can apply L'Hopital's rule again. So, 1 minus 4x derivative gives minus 4, 6x plus 5 derivative gives 6. So, it is minus 6 by minus 4 by 6, or which is minus 2 by 3. So, the indeterminate forms we have met here are of this form, infinity by infinity or minus infinity by infinity and so on. So, that is quite straightforward, but the limit is now to infinity. Similarly, let us find limit of x goes to infinity, x into sin 1 by x. Okay. So, sin can give trouble, that is why it is put this way. We had done it in a different way earlier, but let us see. So, now x sin 1 by x, x goes to infinity. So, 1 by x will go to 0, then sin of that will go to 0, right, but x goes to infinity. So, it is in the form infinity into 0, that is also indeterminate, right. The region infinity into 0, something like you may think of infinity is limit of x square, x goes to infinity, and 0, or you can say 1 by x square, and 0 you can think x, then when you multiply it gives 1 by x, which will be infinity. But if you take 1 by x here for infinity, limit 1 by x, x goes to 0, and this is x square, you multiply, you get x, which will be 0. So, different ways of approaching infinity and 0 gives different answers. That is why these are called indeterminate forms, right. Okay. So, with this indeterminate form, let us see what happens when you apply L'Hopital's rule. But L'Hopital's rule requires it is in the form 0 by 0 or infinity by infinity and so on, not into directly. So, we look at it in a different way. We say t goes to 0 plus, it is 1 by t into sin t, right. So, now again it is directly in the form sin t by t as t goes to 0. So, that we know to be 1, we do not need L'Hopital's rule applying here, fine, that gives direct. But if you apply, of course, you will get the same thing, fine. So, now next problem, we want to compute the limit of 1 divided by sin x minus 1 divided by x as x goes to 0, provided it exists. Okay. So, now this is in the form when x goes to say 0 plus, it is positive. So, 1 by sin x becomes infinity, 1 by x also becomes infinity, it is in the form infinity minus infinity. So, that is also an indeterminate form, because this can become a finite, it is a number, or it can become infinity, or it can become minus infinity. That is why it is called indeterminate form, depending on what way you approach these infinities. Okay. So, what do we do? It is in neither in the form 0 by 0 nor in infinite by infinite form. So, we have to really play with it, bring it to that form, and then we can apply L'Hopital's rule. Okay. So, what happens? We rearrange, we write 1 by sin x minus 1 by x equal to x sin x. If you take the LCM, it gives x minus sin x divided by x sin x. Okay. So, now x minus sin x as x goes to 0 is 0, and x sin x also goes to 0. Now, it is in the 0 by 0 form. You can apply L'Hopital's rule here. So, applying L'Hopital's rule, numerator derivative is 1 minus cos x, and x sin x is, it is f of x into g of x form. So, derivative of a product. So, you take derivative of x into sin x, which is sin x, plus x into derivative of sin x, which is cos x. So, sin x plus x cos x. Now, when x goes to 0, its numerator goes to 0, right, because cos x goes to 1, and denominator also goes to 0. Therefore, you can apply L'Hopital's rule once more. So, minus cosine x gives you derivative as sin x, and this sin x gives cosine x, and x cosine x again you apply product rule. So, that gives plus x into derivative of cosine x plus derivative of x into cosine x. So, these two cosine x are written here as 2 cosine x, minus x sin x, that is right. Fine. So, here the numerator becomes 0 as x goes to 0, denominator does not go to 0, it goes to 2, right, because it is x sin x that goes to 0, but cosine x goes to 1. So, it is 2, therefore, the limit is 0 itself. So, you should not apply again L'Hopital's rule thinking that it is in that form, you have to verify whether it is in that form or not. Okay, is that clear? So, let us take some more problems. Here we are required to find limit of 5x cubed minus 3x divided by 2x cubed plus 1 as x goes to infinity. So, as x goes to infinity, this 2x cubed plus 1 goes to infinity. Numerator is again in the infinity minus infinity form, okay. But it can be thought of as infinity because x cubed dominates x, it will be much larger than x. Therefore, when you subtract, you would get at least sometimes x, right. That is what intuitively means, it will be in infinity by infinity form. Okay. So, then what do we do? We use L'Hopital's rule. So, 5x cubed gives 15x square and that minus 3x gives minus 3, 2x cubed plus 1 gives 6x square. Once more it is in infinity by infinity form, fine. So, we differentiate again numerator and denominator separately, that gives limit x goes to infinity 30x from 15x square, 6x square gives 12x. Now, we do not need differentiation, of course, you can use differentiation, but you can also cancel this x, right, and then take the limit. So, that gives 30 by 12 or 5 by 2. So, here this argument is necessary to say that it is in infinity by infinity form, that 5x cubed minus 3x will be larger than say x, okay, for x bigger than something, say x bigger than 10, you can say 5x cubed minus 3x is larger than x. Therefore, the limit of the numerator as x goes to infinity goes to infinity, that argument is necessary. Okay. So, let us look at the second problem. Here we want to evaluate this limit x goes to 1 of 2x square minus 3x plus 1 into square root of x plus 2. So, it is this one plus 2 and divided by x minus 1. As x goes to 1, denominator goes to 0 and numerator it is 2 to 4 minus 4 times 1. So, it is 0, that is it is in 0 by 0 form, fine. But derivatives will be a bit difficult now, but try. So, we take the derivative of the numerator which is 2x square gives 4x and plus 2 of course gives 0. This one only it is in f by g form, right, derivative of a ratio. So, it will be root x into derivative of 3x plus 1 which is 3, fine, minus derivative of it is minus, now it becomes plus and 3x plus 1 into derivative of root x which is minus. So, x to the power half it gives half root x in the denominator, fine. So, that should be plus sign not minus, this minus and 1 minus comes here and divided by, okay, this, but no, this is not division, this is really multiplication. So, that means we have 3x plus 1 into root x. So, once you have 3x plus 1 into root x, you have the product rule of the differentiation. So, that gives 3x plus 1 derivative into root x and same sign is there, then 3x plus 1 into derivative of root x, that gives 1 by 2, it is correct. So, numerator is this and the denominator becomes x minus 1 gives 1. Okay. So, as x goes to 1, denominator is no more 0 now, but it can be evaluated directly, right, by substituting x equal to 1. So, in that case you get 4 minus 3 which is 1 minus it is 4 divided by 2 minus 2 So, that gives you minus 1. That is the answer. Okay. So, let us go to next problem. Here we want to find the limit of 1 minus cosine of x to the power 6 divided by x to the power 12. So, when x goes to 0, cosine x goes to 1, even x to the power 6 also goes to 1, x to the power 6 goes to 0. So, cosine of 0 goes to 1, and down it is x to the power 12, that also goes to 0. So, it is in 0 by 0 form. We apply L'Hopital's rule. So, derivative of 1 is 0 and minus cosine x sixth. So, first minus cosine of t, that gives sin t. So, it is sin of x to the power 6 into dt by dx, it is x to the power 6, that gives 6 x to the power 5, and denominator is 12 into x to the power 11, right. It is x to the power 11. Now, this is sin x to the power 6 by 12 x to the power 11, and top we have x to the power 5. So, that x to the power 5 we can cancel, we get sin x to the power 6 divided by x to the power 5 when cancels is x to the power 11, that remains x to the power 6. So, this is sin x to the power 6 divided by 2 into x to the power 6. As x goes to 0, x to the power 6 goes to 0, we can write sin t divided by 2t as t goes to 0, and we know sin t by t equal to 1 in the limit. So, answer is half. So, this is pretty straightforward, but only this chain rule has to be applied for getting the differentiation of sin x to the power 6. Okay. Let us take the next one. Here we want to evaluate limit x goes to infinity, x minus square root of x square plus x. So, as x goes to infinity, this is in infinity minus infinity form, fine. We cannot apply L'Hopital's rule straightforward, it should be in the denominator by numerator form. So, what do we do? X minus square root of x square plus x, we multiply this with x plus square root of x square plus x and divide it with x plus square root of x square minus x. So, when you multiply with x plus, this gives x square minus square root of x square plus x square. So, that is x square minus x square plus x divided by x plus square root of x square plus x, and the top one we simplify. So, that gives x square is cancelled minus x divided with the same thing as the earlier. Now, it is as x goes to infinity, it is in minus infinity by infinity form. So, we can use L'Hopital's rule here. Using L'Hopital's rule, x gives us 1. So, it is numerator is minus 1, denominator is x gives 1, its differentiation, and square root of x square plus x. So, it will be 1 divided by 2 square root of x square plus x, 1 divided by 2 square root of x square plus x times derivative of x square plus x. So, that is 2x plus 1. So, this is correct. Then we go to limit x goes to infinity. It is no more in the numerator is infinity or 0 or any of the forms, it is minus 1, and denominator what happens at infinity, that we have to check exactly. So, it is 2x plus 1 divided by 2 square root of x square plus x, 1 plus this. So, you can also do 1 plus this, but that is not required. As x goes to infinity, what happens to this? So, what do we do? We just divide x. So, that makes it 2, this becomes 1 by x, and this when inside square root goes, it is division by x square. So, this becomes 1, this becomes 1 by x. So, that gives you 2 plus 1 by x divided by 2 into square root of 1 plus 1 by x. As x goes to infinity, 1 by x goes to 0 in both the places. So, you get 1 plus 2 divided by 2, which is 1. So, answer is minus 1 by 2.